Good morning, good afternoon, and good evening, wherever you are watching from. And welcome to day 6 of our 12 days Geospatial Python Bootcamp. Today, we will continue our Geopandas. So yesterday, we started with Geopandas, saw a few things we can do with it. And so today, we'll continue with that one. Okay, so the only agenda for the day is that we continue Geopandas. So let us get into VS Code and then see how that one goes. Okay, so what we start with, let me come to full screen. What we'll start with is to learn some advanced query methods. So today, I intentionally do not want to download or use any personal data sets, but you can apply everything that we are doing here to your personal data sets. I'll be using mostly the ones that come with Geopandas, like we explored yesterday. So today, we're starting with some advanced selection methods. Okay. So as always, let me import Geopandas as GPD. And let me select a kernel so that to be recognized. Okay. And I will load the world shapefile or the world data set from Natural Earth, the one that comes with Geopandas. So you saw yesterday that we can load it by saying maybe world DF, short for world data frame. That should be equal to geopandas.read file. And then inside this read file, we pass in geopandas.datasets.get underscore path. And then we pass in the path. So if you don't really know the name of the available data sets, you can print geopandas.datasets.available, but you can also, these pop-ups, are they really? Okay, I don't think this particular thing from our IntelliSense is correct. But if you can put anything that is very wrong here, maybe A, B, C, D, and then you run it, it should throw an error and tell you the things that you can actually pass in. So you see that now there's a value error here that says the data set A, B, C, D is not available. Available data sets are, then it will give you the ones which are currently available. So we see Natural Earth low resolution, the Natural Earth cities, and then NYBB. I will need them also. I'll copy. And then maybe come here and paste them in, comment them out. So they are not proper Python code. So for the first one, what I will load is this low resolution. So I pass it in. And you know from yesterday that I can just say world, DF, and then it will bring me the world data, that data in a tabular form so I can read it and inspect it. Okay. Some of the cool things that you can also check is maybe world.geometry type. If you check the geometry type, it's like a multi-polygon. So I don't know which ones are the polygons and which ones are the multi-polygons, but you can see that the item at index 0 is a multi-polygon. The one at 1 is a polygon, and that one continues. So I can also check the coordinate reference system, and I can see that it is in World Geographic System WGS 1984. And okay, if you want to see all the things that are available on this data frame, you hit Control or Command and then the space bar on your keyboard. When you do that, all of these options here are available for you to use. So there are methods you can perform on the GeoDataframe. So you can see, for instance, the geom type that I typed here was here. And then other things. So you can do other things. Let's see, is it valid? Or let's see the memory usage. Okay. So this is memory usage. I think this should be the bytes because these ones are obviously not. So I think it's the number of bytes that each particular field occupies. Okay, so I was just trying to show you that if you are wondering how to get all the things that you can perform on a particular item like that, if you hit the dots and it doesn't pop up, hit Control or Command space bar, and then you get access to all of these, and then you can try them out. Obviously, we cannot go through all of this, but if one of the things here also is this boundary, let me assign it to maybe something I'll call boundary. If I do this and I go boundary dot plot, it will plot all the boundaries of the files in there for me. So a very quick way of doing this is just to say boundary dot plot, and then this one gets you the boundary, and I can get centroid. Is it centroid, or I think I got a spelling wrong? Centroid, and I think I have to change this name also. So centroid. I think it's the spelling that I'm getting a bit wrong. Let me see how it comes. So that should be in the C column, centroid. Okay, I think I type centroid. So if I go centroid.plot, what is happens is that it gets the centroid or the central part of each of the polygons in there, and then also plots it for me. So if you are looking for the centers of the particular polygons, all you have to do is to call the dot centroid, and that one too will work for you. Okay, so that is it. I just wanted to show you some of the amazing stuff you can perform on your GeoDataframes. You can just hit Control spacebar or Command spacebar after the dots, after you've added the dots, and then you'll be able to get access to all of these cool features to try out. But for now, let's go ahead with our queries. Yesterday, we found out that if I want the Africa PDF, this is Africa. Let me make it Africa countries DF, because there's also one for Africa cities, which we might touch. So that one, if I want to subset only Africa from the world data frame, what I'll do is I'll say world DF, and then I'll open my pair of brackets, square brackets, and then what I'll do is that I will specify that I want where the world DF, there's a particular column, so let's just print it out and see the columns in there so that we can use a particular column for our query. So we can say world df dot columns. Okay, this one will give us all the columns that we have in there. So what I'll do is maybe, no, I don't want to copy this one and paste, but we have population, EST, continent, or maybe I can wrap this one in a print statement in itself so that every time we work around it, it's printed for us. And then when I uncomment this one, now I want it where the continent equal to Africa. So I can say that world data frame subset wherever or select wherever the continent column equal to Africa. And how do I know that it's Africa? Because when we printed out the data to inspect it in a tabular form, you saw that inside the column, the continent names were there. So you can put any continent you want here, and that should work. Oh, sorry, I didn't plot this one. So I can say Africa, countries df.plot, and then that should give us the stuff or the countries in Africa. Great. So in all this, our original data remains untouched. This data, wherever it's located on our PC, remains untouched. All that you are working with is a file which is in memory, and it's just so cool that we can manipulate it any way we want without doing any harm to the original data. When we are done and we want to save our output, it's just the data frame or GeoDataframe.to file, and we specify our driver, whether Esri shapefile or whether GeoJSON or GeoPackage, and we have it exported successfully, even as a CSV. Okay. So this is one of the ways to make a query simple, and this one is we only want it to perform the query using only one column. But what if we want to perform the query using multiple columns? And so that is where we use some of the advanced, so like the things we are used to in ArcGIS or QGIS or any other GIS software out there, where you can perform the selection by attributes. You can actually, in that selection window, you can actually nest things with syntax, which is more or less like SQL. So let's see how we can do that here. We can type SQL like syntax here, and Pandas is able to work with that, and Geopandas is also able to work with that. But we'll not confuse ourselves with the complexities that may come with it. So we'll keep everything simple in a more Pythonic way. So what I want to do now is to get all the countries in Africa that have a population estimate of over 6 million, and then we can add other stuff also to it. So let me give maybe a comment here. So I want countries in Africa, population estimate of 6 million. Okay, let's keep it that way. So I'll delete this one from here. We don't need it again. And so I will say maybe nested. Okay, I would call this one maybe Africa subset or something like that. Africa subset. And then we set that one equal to. So we are still querying from our world data frame. And then this time when I open my square brackets, I want to bring things down so that it will be neat and clean. And so if the queries are a lot, you put them each in a round bracket. So I can say world df, where the continent column is double equal to Africa. When I plug this one to it will work. So let me see. So Africa subset dot plot. And this one, all of them come because I'm looking for all from my query, this should be it. But if I want to nest other things, so in this case where we want to add the population estimate greater than 6 million, we bring this ampersand. And then we can bring the next query in a pair of round brackets. But because I want to keep things neat, I'll bring it on another line. You can type them all on one line. That is no problem. So in here too, what I want to do is to say world df, where the pop estimate pop underscore est is greater than 6 million. And then now, let me run and see. You see, we have some missing values in here. So these are all the countries in Africa. Or let's choose this one rather. Okay, it was actually greater than, sorry. Those symbols sometimes confuse me. So these are all the countries in Africa with a population estimate of less than 6 million. Okay. Wow. Let me use Explore just to see those countries. Okay, this is Mauritania. We have Guinea-Bissau, Gambia, Liberia, and then the Central African Republic, Gabon, Equatorial Guinea. Oh, okay. Okay, that's an interesting discovery because I did not know this. We'll stick with the plot now. So if we want to add other stuff, we can actually add them here. But let me now choose, let me change the symbol and maybe increase this value to maybe 10. Okay, we still have a lot of countries in there, so that's still great. If I want to add more, all I have to do is to bring the ampersand and open up a pair of round brackets again. And so let's say that after this query, we want to also get all of them whose name we want to all the countries whose name maybe contains a particular string, a particular expression. Like I'm sure you can also pass in regular expressions, but we keep things simple for now. But if you have a particular string you want to match, you can use that one also as a query. So in that case, what I'll do is I'll say that after I query the column name like this, I'll add .str. If what your operation, the operation you are performing is an integer operation, just .int, then you can add the other stuff that you can do with integers to it. But this one is an str operation. So str dot contains. And then here, let me just say all those that contain the number, the character n. So when I run this one, oh, we have only 2 countries. That is great. I think maybe we can first, or let's use explore. Niger and Nigeria. Okay. Okay. So maybe let's use A. Okay. Now this is mini. But let me stick to the N because I also want to show something. Uppercase N. There is this option that I can also pass. Now, if I say that the case is false, what I'm telling Python that it should bring out a case insensitive search. So I think it is true by default. That's why it only brought me 2 countries. And in this case, if I set it to false, you see that I have many countries that has the letter N in it, case insensitive N. So at first, it was only taking the uppercase N. That is why I only had Niger and Nigeria. So if you are dealing with strings, you can pass this case sensitivity in there just to keep your query either case sensitive or insensitive. Okay, there's a question here that how can custom population be allocated to various countries in a choropleth map? Okay, let's see. So now we have this data set. How many are they? I don't want, okay, so let's save this particular data that we have, this Africa world subset here. Fantastic. Before we explore it or before we even plot it, let me choose plot. What I'll do is that add a new column to the data frame, and then I will populate it with some dummy data, and then I see how I can use that to address your question. I hope it addresses it. And so add a new column to GeoDataframe. And so maybe the new column, let's call it, because you said population, let me just say population, population. And then let's give it as a list. I want to know let me use the dots count and see. Oh, no, not the dot count. Let me use dots describe. I think I just want to know the number of items in there. Okay. 18. Oh, 18 is too much. Okay, then I will type syntax here, which is a bit weird, especially if you are new to Python. I want to use list comprehension here. So bear with me. Let me import NumPy because I need it to generate some numbers. So import NumPy as NP. And then what I can do here is maybe number for. Okay. I don't have to use a list comprehension if I'm using NumPy. Okay, so that is great because that one might have confused some of you. So all I need to do is to say np.random.randint. I think we have seen this somewhere before. And then what I want to get, there are 16, so I want to get values from maybe 100 million, or how many zeros are there? 1, 2, 3, 1, 2, 3. So this is 10 million to maybe 5 million. No, 50 million, sorry. And then I want to see that like return a particular size. So I will say size here equal to, I want 16. So what will happen is that if I comment this one here, and then I print population, you see that I have a list of 16 random numbers here. So I want to create a new column in my GeoDataframe that contains these numbers so that let me look at the question again. Okay, how can custom population be allocated? Okay, so it's not just about population. If you want to allocate any other particular data set, you can do it this way. You don't usually have to use NumPy. For your case, you might have the data existing already, just that you have to find a way of reading it into a list or any appropriate data set that can be passed to the GeoDataframe. So this printing of the population was not necessary. And so all I have to do to add a new column to the data frame, you see that I've been printing the column all this while, and I don't have a population column. I only have population estimates, shortened as pop est. So I can say Africa subsets, give a comment, adding a new column to the data frame. I think I really like your question. It is making us do something new. I didn't really factor it into this one, but I think it's a very helpful one. Thank you. And so what I have to do is that I type in the name of the new column that I want. So let me just call it population like this. And then I set it equal to my data here. So population like this. Now, when I print the columns again, okay, I don't know which part is giving the error. Length of value 16 does not match length of index 18. How many items do we have in our, maybe okay, the Africa subset, let me print the length of one column and see. So Africa, so print Africa subsets. Let's pick the pop underscore est com dot. I think we should be able to call dot length on it directly. If it is not working, then we try the, because we know that it's a pandas series. Okay, it doesn't have that attribute. Okay, that is not a problem. So we can actually even just convert it to dot list to list, and then we call the Python length function, shortened as len on it, and that should give us. Okay, it's 18. Okay. How did I see the 16? So it's 18 now. So I changed the size to 18. This was just to help get the total item in. And then I run it again. Now, oh no, I'm supposed to print Africa subsets.columns, not world df. So Africa subsets. And by the way, they will be the same. They will be the same because I'm only fetching from this word. You let me just print Africa again so that I will cut all that out. So before adding the population, let me print Africa subset. If I even want to customize it, the more I can say here that maybe before addition, and then this place will be after addition. Okay, so now when I run it, you see that before addition, just forget about this index and other things. You see that this one ends as geometry, and then after the geometry, for the after addition, there is a population field. And for sure, if we think our print statements are becoming too much, if we just inspect the Africa subset. Okay, I think I'm relying too much on intelligence. You see that there's a population column here, which is not in the original data set that we have added. So that is how we add our additional data to the GeoDataframe. Okay. And since we are doing addition here, let me also say that if you want to, okay, the other stuff that you can do, you can maybe rename a column. You can almost all the things that you can perform on a pandas data frame, you can do it here. Okay. I just hope I've answered your question. The person who was asking it. Okay. So let's continue with what we are doing today. I think we're at the place where we were trying to. We finished. I think we finished. We finished the nested queries. Yes. So that is how we perform some sort of advanced or nested queries. Once you understand Python and your data, you can use any of these things to fetch data anyhow you want it. Okay, let me collapse this one. And then next on the list we'll look at is geometric operations. So how to perform geometric operations with Geopandas. Okay, instead of markdown, I chose code. So let me put a markdown at the top. And then the first one, in fact, there are lots of them that we can look at, but let's look at a few of them, and then the rest you will explore on your own. So the first one we'll look at is dissolve. Okay, so quickly, when we import our world data set, I think I will have to go up here. Permit me to copy it. It is here. And then let me paste it. I don't need this one. If we plot this, or let me even use explore to show it well. So world df dot explore. Okay, so when I zoom in, you see that you see each country separate. But what if you want to dissolve this whole file by the continent, so that instead of seeing countries, you only see continent? It's very, very easy. So what we do to do the dissolve is, maybe let's call this one world dissolved, or world df dissolved. Yes, let's call it that way. If you want to dissolve it, all you have to do is to call the data frame you want to dissolve, in our case world df, not the world df dissolved, world df dots, and then you call the dissolve on it. As I said, I cannot teach you all of them, but you see there's aggregate, there is this apply is a pandas data frame object. You can, in case you maybe you want to compute the mean of all of a particular column, like so many things you can do with this data frame. Maybe when we are building some practical examples, all of them will come to play, but for now let's look at these few ones that I have here. So I'm looking for dissolve. You see that is here. And then what do I want to dissolve it by? I want to dissolve it by, so in that case, if you want to know what is in there, it is Control Enter. Some of the okay, this one didn't really come like I'm expecting it, but sometimes the IntelliSense cannot really pick it up. So you dissolve it by which column? And I want to dissolve it by the continent. Okay. So if I choose world dissolved dot explore, now you see that we don't have countries again. It's only continents. So you see that it has dissolved it by the continent. Okay, great. So that is how you can perform a dissolve operation like you do in QGIS or ArcGIS. The next on the list, we'll collapse this one, is clip. Okay. So with that one, I will permit me to copy this one also. And let me add a markdown here. Clip. A code cell, paste it. Oh, let me copy, Control A, Control C, Control V. So what we want to do with this one is that we have the world countries data frame. We also want to get the world cities, because we want to pick a continent from the world data and use it to clip the cities, the whole world cities, so that we can get only cities in a particular continent. So if I also go ahead and let me say Africa or world cities first. World cities. That will not be so different from this. Let me just copy this, paste it here, and then that one is natural earth underscore cities. So we've already seen how the world DF looks like. We have now gone to the place where we plot in layers. We will get to that place soon today. But for now, let me just plot the world cities DF. If I intentionally put, say, a fake size here, like we saw yesterday, a fake size of maybe, this one is landscape. So let me go with 16 by 9 and see. Okay, it's a bit big, so maybe 16 by 12. Okay, it's still cool. So we can see it spread out properly. So what we want to do is to get a particular continent, say Africa, and then clip out all the cities that fall within Africa. So how we go about doing that is, now we have our world cities. We need our clip object, the Africa continent itself. which we know that we can get from, if you say Africa, equal to, then that'll be world df, and then we get it where the world df column called continent has a value equal to Africa. So this one will also give us the Africa continent. We already know that, so I'll not plot it to prove it. And then now we have to do the clipping. So now we can see that Africa cities, that should be equal to world cities. We are clipping the world cities. So world cities df dot clip. And then here we also specify the boundary that we want to use, which is now our Africa. So if I come here and say Africa underscore cities dot maybe plot, I should see only cities that fall within Africa. And if you look at the shape, I think that is it. It's correct. So it's as easy as that. Also, that's how we perform a clip operation. You just have your boundary. It can be a shape file. It can be a polygon layer you have this defined using Shapely. Just make sure that the two are in the same coordinate system. So one of the ways to also check the coordinate system is just to say Africa cities.crs. Okay, we've checked it before, but if you just say .crs, okay, outputs are collapsed. It gives you the CRS, and if I go to the world cities also .crs, I will find out that they are the same. So that means that I will not get a problem performing these geometric operations. Okay. Let us look at the next one. The next one on our list is a buffer. So what I'll do is, let me copy this. We need it. And then we want to create a buffer. Okay, so maybe not all the Africa cities. You can create a subset of the Africa cities, or maybe query it directly. Okay, the Africa cities, I've not really checked the column name, so let me check the columns. If we can subset directly to get a few cities, we will do that. So columns. Okay, it only counts with the name and geometry, so that will not really help. I wanted us to subset all the cities in Africa which has A in them, but maybe a letter like C. Now we have to do it manually like that. So in that case, it should be our Africa, the one that is clipping, that should have those nested queries. So let me perform a few nested queries here. So first it should be equal to Africa, and then the country's name should have maybe N in it, the capital N. So that give me just Niger and Nigeria. Yeah. So if I paste this one also there, and then I change the name here, remember it's not like this. So see .str.contains, and then I'll let it contain only the uppercase N. So now if I, okay, let me plot it rather. I think I should get only 2. Okay, I have 3. Okay, 3 cities fall in there. So let me explore rather and see. Okay. Miami, Nigeria. Okay, Nigeria has 2 towns in the world, and then Niger has 1. Okay. So 3 is fine. I even wanted 2, but 3 is fine. So in this case, we have 3 cities here. If we want to perform a buffer on it, we can just say, let's call it buffer. So we call it Africa buffer. And we can set that one equal to Africa cities dot buffer, and then you pass in the buffer radius here. So let me just put 10 here. And so if we go Africa buffer dot explore, no, let's choose plot for now, not plt plot. Okay, it looks like my buffer was just too big for them, so let me bring it down to 5 and plot. Let the fake size be equal to something like 9 and maybe 16. Let me just swap it. Still very big. Okay, then it means I have to really explore small numbers. Okay, this is not the size, the size of the dots, it is the buffer. So what I can do to really style it is to, apart from the fixed size, add an alpha here, which should be say 0.5, so that I want it 50% transparency. Okay, so that is also how we perform buffers in Geopandas. Okay, so I think we'll use this buffer to initiate ourselves into the plotting with Geopandas. But you may ask yourself, but we have been plotting. Yes, we have, but we have not really plotted anything like layers before. So in this case, ideally, we should have plotted the points and the buffer around it. So let's see how we can do some advanced plotting stuff with Geopandas. Okay, the buffer unit. You know that if you perform a buffer, even in QGIS or ArcGIS, any software you use, the units, okay, some of the softwares allow you to choose a particular unit you want. What happens is that when it is performing the buffer operation, it will convert every CRS. Let me print out a CRS and explain it well. So Africa buffer .CRS. You see that this is in WGS 84. And this is not really giving me full details. I want it to give me the. Okay, so I think did we explore PyProch? So import PyProch. So PyProch. And then maybe the CRS equal to PyProch dot CRS. And let's pass in the Africa buffer CRS. Sorry, Africa buffer CRS here. And let's print CRS dot. I think the other to dict. Let's see whether the to dict will give us all those things in detail. Okay, it didn't also, this one also didn't give the units. But I think, I don't know whether it's because it's not a projected coordinate system. This one, I think the units are in degrees. But let's just assume that we want to also convert this on the fly to maybe WGS, no, UTM zone. Africa is in which UTM zone? The whole of Africa or that part of I think it's from Nigeria, that side. That should be maybe zone 31 or 32. But you let me just pick zone 32 for the sake of demonstration. If you want to do the conversion, please find out the proper zone. Okay. So you remember how we do the conversion? Let me delete this one so that I don't know why I cannot scroll down. Okay. So what I want to do is okay, even in Geopandas, it's fairly easy. You don't have to create a PyProj transformer. Let me show you how to do that. So I can say Africa. Remember when I printed it first here, that is the BGS84. Africa buffer dot to CRS. And then in here I pass in the EPSG code. So there are two ways. I know of two ways. I can say EPSG and then set it equal to zone 32 should be 32632. In that case, if I print out Africa buffer dot CRS, I'm expecting it to give me, okay, we have an error. This is a proj error. PyProj is bringing up this error saying that X, Y, Z, and time must be the same size. Okay, so it's just trying to tell us that there are some components of this our data that we are trying to convert. And these three that is looking out for to be the same are not the same. But all that I wanted to show you is that if you are doing a buffer, it uses the unit of the coordinate system of the data you have. So in the case like Python, where you are not really allowed, maybe it allows us, let's see if we can get a documentation on it to see if it allows us to specify Geopandas buffer, Geopandas buffer specify unit. Okay. So I think this Geo series, usually I like the Stack Overflow answers. Okay, there is even a unit. So geoseries.buffer, this is the Geopandas website. Okay, it takes the distance, even the resolution, and the cap size. Oh, okay, that's great. So there are a lot of things that we can even pass in here. Okay. So let me look at the distance. The radius of the buffer. Okay, doesn't really state the unit, but I think we can pass a unit here. I saw it somewhere. Okay, so I think it's the unit of the data you are using. Yeah, it's the unit. So if you are using a data whose CRS has the unit in feet, then the value you pass in here is in feet. If you are using something that is in meters, then the value you pass in is obviously in meters. But this one, honestly, I don't know the coordinate system. The units of the BGS84, whether it's feet or meters, I've not really explored that, but it was just for demonstration purposes. In your case, you most likely know, but if we want to confirm it, we can search for that one. Unit for the BGS84, units for WGS 1984 coordinate system. Distance unit. Okay, so this one, I assume the answer, but I wanted to see what the internet sources also has to say. It's really difficult because this is Angular. It's not really Euclidean distances that these things are more interested in. This is they are not. That's why this GIS stack exchanges, they are not really meaningful because they are based on lat longs. So usually, if you want to perform distance calculation, as I told you in the beginning, one of the series that has gone before, that if you want to really do distance calculations, you want to project your data into a projected coordinate system, or transform it into a projected coordinate system. So the unit depends on your coordinate reference system. Okay. We're trying to explore the plot side of things. So let me come in and let's see. So plotting with Geopandas. Okay. I think we should take this, everything here, but we'll delete the pipe project. We don't need it. Code cell, paste it, clean it up a bit. And okay, let me leave the buffer. Now I plot this. But what if, let's see other customizations that we can also attach here. Like yesterday, I showed you that if you want to plot, let's say, a choropleth, then you just specify the color side. So for now, I will not plot this Africa buffer. I will plot the Africa cities. So Africa underscore cities dot plot. And if I want to plot a couplet, I just a column equal to, and the column that I want to plot is the name column. Oh, no, Africa cities, Africa dot plot. Africa. I don't want to plot the cities. I'm plotting the. Okay. Looks like this. They are not really plenty like that. So let me just say here that case equal to 4, that I'll get a lot. Okay, so it doesn't really look great, but or maybe you should try and plot the whole of Africa. Oh, no. Let me. No, not NB. Maybe just the B. But I don't really want it. Okay, something has happened. Okay. I'm not looking for plenty cities, but I'll keep these ones that I have here for now. And also, we found out that we can add a legend. Sorry, a legend. If we set this legend to true, our choropleth will have a legend attached. So these are all the countries in there with B, with their legends showing. Let me increase the figure size also. I like to put that at the top most of the time. So fixed size. And then maybe I set that one to be a very big one. Maybe 24 by, or maybe 12 by 24, because of the nature of the African continent. It looks more of portraits than landscape. So 12 inches by 24. Not forgetting my comma. When I run this, where's the error coming from? Index is out of bounds for analysis with size of 2. Okay, I think the values are just too big. So let me just make it 8 by 16. So it's just the same. Maybe I've reduced this small. Is it still big? Wow. So maybe 12 and then 6. Okay. I don't think that is really the issue. I don't know why this fixed size is not working. Let me comment this part of the code. But I don't know why this thing is not working. Big side. Oh, okay. I've misspelled it. Sorry. Big size. Some of these error codes, they are not really that friendly. Instead of it telling me that I've misspelled something in there, so it's just telling me that index something. Okay, so now I have a bigger map with my legend to the side. And we saw also that we can even add other customizations to our legend. So if we want to maybe rename the legend or say something about the legend, change the position as our plot. Okay, let this buffer be there. I'll add it very soon. We can add another one called legend underscore KWDS, which is dictionary. So legend keywords, you can think of it like that. That's how I keep it in mind. I can give a title, which is called a label to my legend. So maybe let me say African countries with letter, that would be a long title for a legend. Letter B. Let's see how it goes. Okay, it says it doesn't know label, which is weird because I didn't get the spelling wrong. Label. Or its title. Because I know of label. Okay, maybe the label is deprecated and now it is title. So you can see that the title of the legend has shown there. And then we can also add stuff like the orientation. For now, you see that it is vertical. I can choose to make it horizontal. And I'm going to run it. Okay. I think then most of this stuff are really deprecated. Let me just choose orient and see. Okay, and that one also did not really work well. Let's go back to the internet because I know for sure that this one should work. So, yeah, matplotlib legend keywords. Okay, let me see the one from Stack Overflow. And let me just open the matplotlib documentation also. So let me come down. Okay, this one is specifying legend location. That's not what I'm looking for. I want the legend keywords. Okay, so this is the keywords that we can pass. Let me look for title. Title is here, the one I used. And so let me look for something that will talk about orientation. Or they've taken it out. So location. Okay, this shadow tool is something cool that we can explore. But I was looking for the orientation. Maybe now it's not there. Okay, sorry about that. But I used to use it on my maps and all that. Okay. So in case you are wondering, these are all the things you can pass into your legend there. So you just have to search for matplotlib legend keywords, and that should bring you there. So it says that we can pass a shadow of true. Let's see what that one will do. And it's tried to give it some shadow. Okay. So that's great. So that's the legend and all the other customizations too. When you just search for Matplotlib legend keywords, and click on this link that says legend Matplotlib documentation to bring you here. You can scroll down. I know it's a bit technical, but just focus on the less difficult parts. So you can see that when you come in here, these are all the things you can pass and all that. But if you scroll down, I think they break it well in this table for you. And if you want to pass a font property, the font size, the marker size, and all that, you can do that there. Okay. Even the number of columns. So let's see. Encores. I think, yes, yesterday I promised this one, and great that we have found it. So encores, let's just make it 2 and see. Okay, that is great. So that gives us those number of columns. And so I think this one will be very handy if you have all the Africa, if you plot all Africa. Africa. So let's take this query off. And delete this ampersand. Yep. So that we have all of Africa. In that case, we can, when we have the long like that, we can simply, but that one also, then in that case, we have to find a way of making the figure size so big such that, and reasonable also such that the legend will not really cover stuff. But we can change the location also, as we saw in the documentation by the lock keyword. If I should maybe change this one to 3 and then add a location. The location, they have specific rules for that. Let me take a look. I think it is down here. When you scroll down a bit, not this one. Location. Okay, so the location code. If you want upper right, you put 1. If you want, I think the default is 0, which is the best, which means that Python will look at where to put it. But this one, I want to put it at the lower left, and the code is 3. So I can come back, and I think if you type lower left, it should work. In case you can't remember all the code like that. Okay, it didn't. Okay, I shouldn't bring space in between. Okay, so one of the cool things is that if you make a mistake in these things, sometimes it shows you what the right value is. So let me just delete the underscore, and then that will do. So I thought that there was a lot of space down here, so I could bring it here, but still I have to adjust my figure size a bit. So that is it also about the legend, how we can customize it, make it multiple columns and all that. You just have to bring this legend keywords here, and then you are good to go. Okay, let us continue with the plot customization. We've already hit an hour. Okay. And yesterday too, we explored the colors. So you can add a particular color, and then that one you add it using CMap. Yesterday, I think I showed you that. I think the favorite I have found so far is Viridis. Okay, I have to bring a comma here. Okay, this is the one, the color code that I like the most. And so I think it is best suited for, not for this particular purpose, but I still like it. I like it, it's so nice. So you can change the color code. And once again, if you want to know the color codes that are in there, and you cannot really search the internet for it, just put something that is very wrong in here, like ABCD, which I'm not sure is part of the color code, to throw an error. And then it will tell you here down there that ABCD is not a valid value for CMAP. Supported values are and it will list all of them for you so that I can choose from them. So let's just say I choose pet, come back here, and then I'll change it. As I run it, now it will be coming because it knows pet as, oh wow, this is also very great. Very, very nice. I think it will be my second favorite. Pet. It's nice. Okay. So that is it also about adding legends and choosing colors. I've only shown you that we can plot the boundaries. So what if now you want to plot map with layers? Okay. In that case, we have to now, how do you call it? Find a way of plotting one before the other. So we kind of have a base map or something like that, and other ones will now add up. So this one that we have here can now be our base map. So to get it that way, what we have to do is to assign a name to it, maybe base equal to then Africa plot. And then if you want to add anything to this one, Africa cities, is it selecting everything in Africa? Yeah, that will select everything in Africa. So let's not add the buffer of one. No, let's not add it for now. Okay, we can leave it here. We can plot the buffer 2 on it. So here will be add Africa cities layer. Okay. And so what we do is to say Africa, we call it Africa cities dot, then we call plot. And then inside here, we specify that the axis, usually we don't put anything here, but now we have to specify that the axis equal to whatever we want to plot it on. In this case, our base. Okay, so now let's run it and see. Now you see that the Africa cities that are inside there are on the African polygon. Okay, this is our legend. Should we take it off? Maybe no. Or if I bring this thing down, the only way I can increase my figure size is to bring down the font of my code editor, which will not also be very good for you. So just bear with me, let it be there in a very uncomfortable way. And then let's continue. So we can have it here on top of that, on top of all the polygons like this. Let's say we want to plot the buffer also beneath the cities, but above the polygons. In that case, let's bring it up. So it plots it in the order. We find out we can actually change it, but for now, let's look at how it plots. It plots it in order. So if you want to change it, then we can change it. But now, it plots it in order. Just keep that one in mind. Okay. Africa buffer, and then we can say Africa buffer dot plot, and this one to specify the axis as base. So when we run this one too, we should see the buffer before the point. Okay, they are all there. They are all there. But what is happening is that the buffer's alpha is 100%. So we can change the alpha here to maybe 0.4, which is of 4, which is 40% transparency. And in that case, we will see you see that the buffer is rounded and the points are there. I don't know whether the blue color is so visible on your screens. Maybe I should make the points color black. I'm just hoping that there's a color attribute like that I can just set equal to black. Okay, so that one works, and we see our buffer there. If it doesn't really appear on your screen, you can, for your site, it works. Actually, it works. Maybe the transparency is too low. So If I bring it up, I think this one should be very visible for you, the 50%. Okay, so you can see that we are now plotting layers on this particular, like this map is steam, this is in layers. So whatever it is that we want to do, we can do it. In fact, if you want to also plot the boundaries, maybe you can plot the boundaries, just the boundaries. So we can say Africa, how did you call it? Just Africa dot boundary dot plot. I just want to plot it straight away. And then I'll specify the AX equal to base. But because this is a hollow polygon, even if it occurs at the top, it shouldn't really be a problem, because unless in the cases where, okay, this cases where it cuts across the cities that are at the edge of the African continent. So now, how do we specify the order? If in case you are plotting a lot of things, I think it's a bit cleaner to make sure that the ones that should be at the bottom are written first in the code. But in case you still have to put something there before another, but still want it to be at a particular place in the code, then in this plot, we can specify what we call the Z order. If you have done anything with development and you start with CSS and co, you should be used to what we call the Z index, which is just an index, a number, an integer that specify. So if you have a Z order, if you have 3 items and they have Z orders of 1, 2, 3, that means that the one with the index of 3 will be on top, and then the other ones will follow in that manner. So if I say a Z order of, say, 1, and then I run it, let's see what will happen. Now, that one works, but we have not specified a Z order for the rest. So this one alone will not really solve the problem. So the thing that we can do is the Africa itself. Let's give it a Z order of 0, because that's the base. Or let's just start from 1. And then we want the polygon to be 2, so I put it 2. Then the buffer should now be 3. So Z order of 3. And then this one here now should have a Z order of 4. Okay, I put it at a place that is supposed to. It's not supposed to be. Now when I run this, okay, you see that even though the boundary comes last and is supposed to be on top and shadow the buffers, is still behind it because I've specified the Z order. Maybe that doesn't really show well. Let me just specify a color of, say, which color will be so bright? Red. And then is there a line width or weight? One of them. Let's just hope that line. Is it line width? I think width. Let's set that to 5. Okay, so that will be very big for us to see. Okay, I don't know whether it's so visible on your screens, but you can still see that the buffers are not being covered by the red lines. For instance, if we zoom in here, or even the Explorer will do it better. I've even forgotten. So let's just put Explore on this one, because that's the base. Okay, it's not really allowing us the flexibility to do that. Okay. But if you look at it carefully, you see that it is still beneath it. So that is also how to specify stuff with the Z order. Okay. So other customizations also that we can have Yesterday, someone was asking question about how do I get the axis off or something like that. If you want to get the axis off, where is it? This is our base. We can come here before it's shown. We can come here and see that base dot set underscore axis. It's even IntelliSense is even giving it to me. Set axis off. Once I call this function, the axis should all be gone. Okay, so now I don't have the axis telling me all those grid and stuff. Okay, the grid also, let's see. So base dot. And so if you want to know all the things to do with this thing, to just say base dot, and so that you have a lot of things to do here. You can add a table, a line, an image, all of these that we cannot go through now, but you can explore them on your own. Let me see if the grid side. It looks like a lot of things have changed since I used the Matplotlib. Let me see. Okay, that's great. I think there's a way to specify the style, but I forgot. Okay, we will specify a wrong style name, and we know that that one will give us the correct styles that we can use. Okay. Let me see. I think it should show, but it's not. So Matplotlib, great keywords. Yesterday I told you that it's PyPlot that does it. So once you see the link that goes with PyPlot, you can choose that one. Okay, try again. That link is from Matplotlib. Why is it not working? Okay, this one has worked. So we now see that great. Where is it? But we called it. Why was it not coming? So we can even specify whether the axis is singular or both. But I'm looking at, or because the axis is off. Let's turn on the axis and see, because I don't know why the grid should not show. Okay, so it was because the grid was actually set off. It does make sense because you should have a grid. But why will you have a grid without the axis? So this is it. We can have a grid here, and we found out on the documentation page that you can even specify a lot of things here like this. So we cannot go through all of these. You can once again. That's why you see I show you how to do some of these things by doing real-time internet searches. The goal here is not to try to keep everything in your mind. No. If you do that, you will actually be carrying old information, because you saw that when I was trying to assign a title to this legend, I was still using the old information that I had that said label. Meanwhile, they have changed the documentation to something else. So okay, so while zooming the stream cuts, does that mean that the stream stopped at a particular point in time? Sorry about that. Okay, so I was trying to use the old knowledge that I have label, and it was not the case. So I have to now do a search. So the goal as a good analyst or even a programmer is not to try and cram everything in your mind. No, just understand the frameworks, understand the basics of a language, how to do this and that, and when to use this and that, and then have good internet search skills. That is also a great plus to any good developer or programmer out there. So we just search for it like this, like I did, and then the ones that lead to the documentation, or maybe trusted sites like Stack Overflow, those are the best ones you should follow. So it's even saying here that animated, meaning that the grid can be animated. Well, we can look at that one. I'm looking at something maybe called the intersection, if they have something like that. Okay. Looks like they don't have it. So let me look at the animated and see. It should be an interesting. So grid, and I set animated to be true. So where's the animation? It looks like we don't have an animation here. Okay. So now somebody will ask, so how do I add a title here? Okay, it's just so easy. Maybe base dot. If you do base dot, your IntelliSense should bring things up. If it doesn't bring it up, control or command space bar, that should do it. You see base dot title or set title. I think when we use figures and co like this, let me try the set title first. As a case, we use the set title. Let me say Africa countries. Okay. And my legend, let me change this long name to countries. Okay. Okay, I have it here. This one too can take in a lot of argument. Maybe I think this one, I'm not sure if change it. I know of font size. So if we set it to be 22 and maybe font weight, set that one to be I don't know whether the words like let me see. I think it should be a number. Let me put it at 5 and see. Okay, so it did work. So I can modify these things. If you want to know the properties you can pass here, you can just always come to the internet and then matplotlib, set title, keywords, search for something like that, and then usually look for the one with the documentation. Jigs for jigs is also a good place. And then you see this axis or set title, that is the one that we are doing because this base that was there is actually an axis that sorry, I forgot to mention. So we have a font dictionary here. So all these things you can pass them in as a dictionary or as individual ones like I was passing in. So the font size, the font weight, and the vertical alignment and all that. So even they have other keyworded properties that you can pass in for text. Let's see that one. So if you come to those keyworded arguments too, you can pass in other so many things here that you might find useful. Okay. So that is it also about the customizations using. I cannot teach you everything there is about this. Maybe if we are building some one or two practical projects, that most of these things will come to mind. But I cannot teach you everything that you can do with this legend. If you want to plot a thematic map, just define a base, call the base layer you want to plot, and then now that becomes your axis. With that axis, you can plot everything and assign to it. Remember, it's like folium, the map, and then you assign everything to the map. And so this one, to just plot a base and assign everything to the base. It's just so easy like that. And if you want to add other things to your map and style it, you can just call the base axis and then do dots. Just wait for some time or hit control or command space bar. And all of these things are there for you to explore. If you don't know any of them, but you want to know what it does, just click on it like that. Yeah, let's just pick this contour. We are not doing contour here, but you can just copy this come to the internet, as I said, make use of the internet a lot so that you'll be current in knowledge. So that is matplotlib access. Remember, we are using access dot contour. So you paste the contour and add keywords like this. So you see that one that goes to their documentation, and it will tell you to plot that this one plots contour lines. Okay, fine. Now you see that it's contour. You can pass in your X, Y, and the Z. So you can read about it and then know how to put it and what to do. As easy as that. Okay. Friends, I think we've passed the hour for quite a number of minutes also. So let's end today's stream here. And we covered all that we had to cover up to this, plotting with Geopandas, advanced stuff, and then plotting on axis and all that. You can explore these properties with the Explore tool to make the maps interactive. Okay, so as always, I'll leave like a minute. If there are questions that I have to address, then I do so. Other than that, then we call it a day. Okay, so it looks like there are no questions. Thank you very much for joining today's stream. It has been a pleasure with you as always, and I will try and upload it immediately afterwards. Yesterday I had some issues with my network. I don't know, the stream was fine, everything. The stream is fine, so the network is actually good, but my upload speed was very, very low, so I couldn't do the upload in the evening. So once again, thank you all for joining, and have a great day, all of you who are still in the day, and have a good night, all of us who have to retire to bed. Until next time, it is goodbye.